Hello everyone, my name is Marko and I'm currently a second-year master student at the University of Zagreb. Welcome to my presentation about strong heuristics for named entity linking. Let's first start with the motivation for the use of heuristics. Named entity linking in the news is a challenging task due to the high frequency of unseen and emerging entities. This can be seen in a recent example of an article about Uvalde school shooting, where we can see 4 different entities which were likely not featured in any article prior to the event. For this reason, unsupervised and zero-shot approaches are necessary. Recently, Arora and others proposed an unsupervised entity linker, Eigenthemes, that leverages relatedness of entities that are mentioned together in an article, but does not make use of mentioned context. AIDA-CoNLL and others proposed mGENRE, a powerful but computationally expensive transformer-based zero-shot entity linker. In our work, we investigate the suitability of lightweight, scalable, and interpretable heuristics for named entity linking. We use entity popularity, entity-content similarity, and entity-entity similarity as the main signals and use Wikidata as the referent knowledge base. Let's first describe the entity popularity signal. We link a mention to the most popular candidate entity and obtain the best performance by measuring the number of Wikidata site links and PageRank computed on Wikipedia. The obtained scores for 2 entities named Donald Trump are shown below. Clearly, the former American president is more popular than the physician and has a higher number of site links and PageRank. Let's now move to the second signal, entity-content similarity. We link a mention to an entity whose Wikidata item is the most similar to the article content. We obtain the best performance with I-score, a heuristic that simply counts unique matching non-stop words in the article and the Wikidata item of an entity. We also experimented with a narrow version of I-score, which is computed only on the sentences where the mention appears instead of the entire article. In this example, Brian McDermott mentioned in the text refers to a rugby league coach. His I-score is simply computed by counting words appearing in the article and his Wikidata item shown right. His I-score is thus 5, while his N-I-score is 1, since only league appears in the same sentence as Brian McDermott. Final signal is entity-entity similarity. We link a mention to an entity most similar to unambiguous entities mentioned in the same article. Unambiguous entities are the entities mapped to mentions with only one candidate. The best performance is obtained with entity-entity I-score, which is simply a count of matching Wikidata statements of an entity and all the unambiguous entity that appear in that article. Let's illustrate this in the same example shown earlier. In this article, there are 2 unambiguous entities, Kevin Sinfield and David Ferner. Brian McDermott has 6 statements that match statements of Kevin Sinfield or David Ferner, thus his EEI score is 6. We also experimented with the combination of the heuristics and obtained the best performance with UI score, which is simply a weighted sum of I score, N-I score, and entity-entity I score. Weights of UI score are optimized on a validation set using grid search. We evaluate the performance of our methods on Quotebank and AIDA-CoNLL. Quotebank is a large web-scale corpus of attributed quotations where all the gold entities are humans, while AIDA-CoNLL is a standard entity linking benchmark with 4 types of entities: person, location, organization, and miscellaneous. Let's proceed to the results. In this table, precision at one of the methods is shown. mGENRE achieves the best performance. When it comes to heuristics, on Quotebank, UI score performs the best, while on AIDA-CoNLL, combining the heuristics does not improve the overall performance, so the best performing heuristic is I-score. Popularity heuristics perform similarly to each other. In this table, we show the per-mention inference times of the methods. Here we can see that the best performing method, mGENRE, is several orders of magnitude slower than the heuristics and Eigenthemes. Since popularity heuristics boil down to simple dictionary lookups, they are arguably the fastest. Finally, we show the performance of the methods when linking different entity types on AIDA. UI score performs the best on person-type entities, which is in line with the results on Quotebank, where all the entities are people. Eigenthemes achieves the best performance on organizations, while mGENRE performs the best on locations. Interestingly, popularity heuristics are the best for miscellaneous entities. To sum up, strong performance and low computational complexity of the heuristics suggest that they can be used as strong baselines for large-scale unsupervised entity linking. The heuristics perform particularly well when linking mentions of person-type entities. Thanks for your attention.